What happens to your body when you don't eat for 10 to 12 hours? The hour-by-hour physiology of short-term fasting. Introduction. I want you to stop for a moment. Close your eyes, just for a second, and think about the last time you felt truly well. Not just okay, truly well. Clear-headed, light, energized, at peace inside your own body. Now, here's a question that most doctors never ask, and most people never think about. What if your body has been trying to give you that feeling every single night, and you have been accidentally interrupting it? Because here is what modern science has quietly discovered, buried inside the pages of Nature Metabolism, Cell Metabolism, and the world's most prestigious medical journals. Your body does not just survive the hours when you are not eating. It transforms. It repairs itself. It cleans its own cells from the inside out. It switches to a cleaner, more powerful fuel. It releases hormones that protect your brain, your heart, and your muscles in ways that no pill, no supplement, and no superfood has ever been proven to replicate. And it begins doing all of this approximately 10 to 12 hours after your last meal. 10 to 12 hours. That is the time between dinner and breakfast for most people. That window you spend asleep. You are already, without knowing it, standing on the edge of one of the most powerful biological transformations the human body is capable of. So the question is not whether your body can do this. The question is, are you giving it the chance? Today, we are going to walk through every 2-hour window of your fast, from the moment you put down your fork all the way to hour 12, and show you, with the precision of peer-reviewed science, exactly what is happening inside you, in your liver, your fat cells, your hormones, your brain, and right down to the molecular machinery inside each of your cells. What you are about to learn will change the way you see every meal you eat, and every meal you choose to skip. Let us begin. Why this matters. Research from PMC 2024 confirms that blood ketone levels begin rising between 8 and 12 hours of fasting, reaching 2 to 5 millimoles per liter by 24 hours. The 10 to 12 hour mark is a genuine metabolic tipping point, where the body transitions from a sugar-burning machine into a fat-burning, self-repairing, hormonally optimized system. And it happens while you sleep. Hours 0 to 2, the fed state, digestion, insulin, and storage. The clock starts the moment you finish your last bite. For the first 2 hours, your body is in full absorption mode. Food moves from your stomach into the small intestine, where enzymes break carbohydrates into simple sugars, proteins into amino acids, and fats into fatty acids. These are absorbed into the bloodstream, causing blood glucose to rise. Your pancreas immediately releases insulin from its beta cells, the biological key that unlocks your cells and allows glucose to flow in for energy. Your liver and muscles absorb the remainder and package it into glycogen, your body's short-term energy reserve. Any glucose beyond storage capacity is converted into fatty acids and deposited in adipose tissue as triglycerides, your long-term fat stores. By the end of hour 2, digestion is largely complete. Blood glucose normalizes. Insulin begins to fall. Gut motility slows. Your body is shifting from active absorption into post-meal calm. And the real physiological story is only just beginning. Hours 2 to 4. Glycogenolysis activates. The liver takes command. By hour 2, the supply of nutrients from your last meal has stopped. Your brain, red blood cells, and entire central nervous system depend on a constant supply of glucose. And there is no more coming in from food. So where does it come from? Your liver. It stores approximately 80 to 100 grams of glycogen. roughly 320 to 400 calories of immediately available glucose. As insulin falls and its counter-hormone glucagon rises from the alpha cells of your pancreas, the liver receives a clear signal: release the reserve. This is glycogenolysis. Glucagon activates glycogen phosphorylase, which cleaves glucose units from the glycogen chain, ultimately producing free glucose released directly into the bloodstream. Your blood sugar is maintained within a tight range, typically 70 to 100 milligrams per deciliter, even though you have not eaten for hours. This is not willpower. This is ancient biology. You may notice the first whisper of hunger around this time. The hormone ghrelin, produced by your stomach wall, begins rising and travels to the hypothalamus to generate the sensation of appetite. But as you're about to discover, that feeling is far more negotiable than it seems. The insulin-glucagon seesaw. When you eat, insulin dominates, storing glucose, building fat, suppressing glucagon. When you fast, glucagon takes over, mobilizing glycogen, activating fat breakdown, and, as we will soon see, triggering some of the most powerful repair mechanisms in human biology. Hours 4 to 6. Insulin falls. Your fat cells open. By hour 4, insulin has dropped significantly. And this single change unlocks one of the most important metabolic events in the entire fasting process. Insulin is not just a glucose management hormone. It is the body's master fat storage lock. When insulin is high, fat cells are sealed. When it falls, as it is now, the lock opens. Two enzymes previously suppressed by insulin are now activated. A TGL, adipose triglyceride lipase, cleaves the first fatty acid from a stored triglyceride. HSL, hormone-sensitive lipase, cleaves the second. A third enzyme, MGL, releases the final one. 3 enzymes, 3 fatty acids, each stored fat molecule completely dismantled. This is lipolysis, and your fat-burning engine has just switched on. These freed fatty acids travel to the muscles, heart, and kidneys, where they are burned in mitochondria via beta oxidation to produce ATP, the universal energy currency of every cell. Your liver also begins converting a portion into ketone bodies, an alternative fuel that will become critically important in the hours ahead. Research from PMC 2024 shows that amino acids, lysine, leucine, isoleucine, and taurine also begin declining in the bloodstream as the body draws on them for gluconeogenesis, manufacturing fresh glucose to keep blood sugar stable. Research data. PMC studies show alternate day fasting over 8 to 12 weeks produces 20 to 25% reductions in LDL cholesterol and 15 to 30% reductions in triglycerides. The lipolysis process switching on right now in hours 4 to 6 is the very mechanism driving those extraordinary lipid improvements. Hours 6 to 8. Gluconeogenesis. Your liver manufactures glucose from scratch. By hour 6, your liver's glycogen is being meaningfully depleted. And yet, your blood sugar remains stable. How? Because your liver has activated one of the most sophisticated biochemical processes in the human body, gluconeogenesis, the synthesis of brand new glucose from non-sugar raw materials. The raw materials come from 3 sources: amino acids, particularly alanine and glutamine from muscle tissue, are sent to the liver, stripped of nitrogen, and rebuilt into glucose. Glycerol, the backbone molecule freed during lipolysis, is converted into glucose, and lactate, produced by red blood cells and working muscles, is recycled back into glucose via the Cori cycle. Your liver is literally manufacturing sugar from the building blocks of your own body. Cortisol rises modestly during this window. Far from being purely harmful here, cortisol drives gluconeogenesis and mobilizes fatty acids, ensuring the brain stays supplied. Simultaneously, growth hormone begins its pulsatile release from the pituitary gland. the first sign that the body is preparing to protect your lean muscle mass as fuel sources shift. Any mild hunger or fatigue you feel right now is largely psychological, driven by habit, not metabolic crisis. Your blood sugar is being maintained. Your brain is being fueled. Your physiology is working precisely as designed. Hours 8 to 10. The metabolic switch approaches. Fat becomes the dominant fuel. By hours 8 to 10, your liver's glycogen stores are nearly depleted, and your body responds not with alarm, but with a beautifully coordinated shift to its most powerful, longest-lasting energy source, your fat. The architect of this transition is human growth hormone, HGH. Suppressed by insulin when you eat, growth hormone is now surging in pulsatile bursts from the pituitary gland. It simultaneously accelerates fat breakdown from adipose tissue and protects lean muscle mass by promoting protein synthesis in muscle cells. Burn fat. Spare muscle. This is evolutionary genius. Growth hormone also signals the liver to produce IGF-1, insulin-like growth factor 1, which promotes muscle cell survival, bone growth, and tissue regeneration. Fat oxidation is now the dominant fuel pathway. The liver is converting fatty acids into beta-hydroxybutyrate, acetoacetate, and acetone, the three ketone bodies, which are being released into the bloodstream and crossing the blood-brain barrier. Your neurons are receiving their first meaningful dose of this alternative, cleaner-burning fuel. Many people report improved mental clarity and focus at exactly this stage. The science explains precisely why. Why athletes and clinicians engineer this state. Research from PMC 2024 confirms that elevated growth hormone, low insulin, and rising ketones together create the optimal environment for burning fat while preserving lean muscle. Time-restricted eating protocols are not a wellness trend. They are deliberate access to this exact biological state. Hours 10 to 12. The metabolic switch, ketogenesis, Nobel Prize science, and cellular renewal. The 10 to 12 hour mark, your body crosses what researchers call the metabolic switch, described in a landmark review by Professor Mark Mattson in the journal Obesity, 2018, and validated by dozens of controlled trials since. The body is now decisively transitioning from glucose-dependent to fat-dependent, ketone-fueled metabolism. Every system is responding. In your liver, glycogen is significantly depleted. The enzyme HMGCS2 has been activated via transcription factor FOXA2, turned on by glucagon through acetylation. Beta-hydroxybutyrate and acetoacetate are pouring into the bloodstream. Oxford's Endocrine Reviews, 2025, describes this FOXA2 glucagon molecular axis as one of the most elegant regulatory systems in human physiology. In your brain, neurons are now running on ketone fuel. Ketones generate more ATP per molecule than glucose and produce less oxidative stress. Mattson et al.'s 2018 paper in Nature Reviews Neuroscience documented that this metabolic switching promotes neuroplasticity and upregulates BDNF, brain-derived neurotrophic factor, the protein critical for memory, learning, and protection against neurodegeneration. Your brain at hour 12 is not struggling. It is being upgraded. Inside your cells, the most extraordinary development, two master molecular switches are now active. AMPK, AMP-activated protein kinase, the cell's energy sensor, detects the drop in ATP and fires, initiating formation of autophagosomes, membrane-bound structures that engulf damaged proteins, dysfunctional mitochondria, and cellular debris. Simultaneously, mTOR, mammalian target of rapamycin, is suppressed, giving the green light for autophagy to begin. Autophagy, from the Greek for self-eating, is the process by which your cells dismantle and recycle their own damaged components. Professor Yoshinori Osumi received the 2016 Nobel Prize in Physiology or Medicine for discovering its molecular mechanisms. His Nobel lecture called it one of the fundamental survival mechanisms of all life on Earth. Damaged proteins broken down, worn-out organelles recycled, components rebuilt into new, healthy structures. This is cellular renewal, happening in your body right now, 12 hours after your last meal. The clinical evidence confirms it. The landmark Sutton et al. Study in Cell Metabolism, 2018. The first rigorously controlled, time-restricted eating trial showed improved insulin sensitivity, blood pressure reductions of 11 millimeters of mercury, and reduced oxidative stress, all with zero weight loss. Participants ate the same calories as the control group. The benefit came entirely from the timing of the fast. A network meta-analysis of 99 randomized trials, 6,582 participants in the BMJ 2025, confirmed fasting reduces body weight, improves fasting glucose, and reduces insulin resistance safely across the general population. Conclusion: every night, your body is waiting. After your last meal, your body shifts through a defined metabolic sequence. Insulin rises and stores energy. Glycogen maintains blood glucose. Insulin then falls and lipolysis begins. Glucose production and growth hormone increase. Fat oxidation rises with ketones fueling the brain. And by 10 to 12 hours, the metabolic switch activates, with ketogenesis established and autophagy initiating its regulated cellular renewal process, described in the Nobel-recognized work of Yoshinori Osumi. This is not a trend, but normal physiology, and allowing roughly 10 to 12 hours between meals often permits this transition to unfold. Medical disclaimer: this content is for educational purposes only. If you have diabetes, are pregnant, take medications, or have any medical condition, consult a qualified physician before changing your eating pattern.